My name is Sakib and I'm going to be a host today. Most of you by now must have attended my webinars, and you might be aware that I am a product lead at GMAT, and I've also been the principal architect of the product that you, most of us students that basically use on our platform. I love teaching quant, and especially today is one of my favorite sessions. I like teaching geometry a lot. I like solving geometry a lot. It uses a lot of visualization skills, and I kind of find it very fascinating to look at diagram, try to figure out info different information from the particular diagram. Those kind of things quite intrigue me a lot. So I hope you'll also enjoy this webinar today. And once again, the progression of the webinar is going to be straightforward. I'm going to jump right directly into the topic. And in this webinar also, I've tried to kind of cover a bit of both, little bit of theory as well as some good variety of questions, some common pitfalls that people usually fall for in the exam. In this webinar, I'm also going to focus a lot on skills, which I usually do in most of the webinars, but especially in this one because in geometry, without having a really solid foundation of visualization, solving questions of geometry can be really difficult. Okay, so I'll be focusing on that and how you can approach a geometry question also, because a lot of students don't know which formula to use, how to use it, what should be the progression of that formula. So I have taken a few questions where I'll be specifically focusing on showing you how you should think about starting the problem. Okay. And I've kept about 10 minutes at the end in case if you have any queries related to any questions that we might have, want to rediscuss again, or if you have any general queries regarding quant prep or GMAT prep in general, please feel free to ask them at the end of the webinar. I'll be more than happy to answer all your queries. Okay. With that, let's start off with the topic. Geometry, if those of you already started might already be aware, but those of you are starting, keep in mind that geometry is kind of divided into two main parts, and that is how I basically segregate it. One is the basic concepts, and when I say basics, what I mean by that is that it is non-negotiable, and I'm writing it down also, that make sure that it's like really important that you know all the formulas for all these topics that I've written down here. Okay, it's like kind of non-negotiable. If you don't know the formula, you will not be able to do anything at all in when I say formula, I mean properties also, by the way, right? Formulas are there, but in geometry, the properties, the rules that are there are related to each and every entity, like triangles, quadrilateral, circles. If you're not aware of it, you'll not be able to do anything, right? And that's not the same for some other topics. Like, say, for example, word problem. If you know how to solve, an equation, and if you know how to set up an equation, maybe logically you might read the question, set up an equation, still be able to solve it, even if you don't know a lot of theory. Same goes for number properties. You might solve some number questions also by just using pure logic also. You might not even need to know any formula as such. But in geometry, unfortunately, if you don't know, the total internal angle of a polygon, or if you don't know about how the chord works, properties of a circle, you won't be able to do anything at all. Okay. Apart from that, and some of the favorite topics I would say especially in recent times in GMAT, is coordinate geometry. I would say this is like one of the most important topics that I would want you to kind of focus on, especially questions which are based on slopes and lines. In fact, I've taken one question which is based on slopes visualization, and which I am really interested in discussing today. And these will show you how knowing the properties of slopes, what is a positive slope, what's a negative slope, how do they look, or what do they look like, and how does that affect your answer based depending on the type of lines that you're dealing with. Those things are very neatly covered in that particular question, which I'm going to discuss today. So keep in mind, if you haven't started preparing geometry and you want to do well in it, you should definitely, the first thing that you should do is make sure that you know all the formulas and the properties of these topics. Okay. And as I told you, visualization will always be one of the key things that you will have to focus on if you want to do well. Okay. Now, I'm going to do is I'm going to start off with the questions. In fact, I have a query in the chat box, so let me just answer that very quickly. So Rahul asking, where can I find all the old webinars? Rahul, I'm sharing the YouTube link out here. If you go to this YouTube link in our playlist, you'll see there'll be a playlist on all the webinars that we have conducted, countdown to round 1 webinar series. You can look at that and you'll be able to find all the old webinars there. Okay. Now, coming back to this session again. Guys, what I'm going to do is, again, follow the same principle. I'm going to give you a question. I'm going to give you some time to solve it. And in this case, what I'm going to do is, I'm not going to give you the theory first. Okay, like in permutation, combination, the previous topics, I used to do some part of theory and then question. But here, I'll be doing just the opposite. I'll give you the question. Those of you who know the property will be able to solve it. Those of you who don't will then appreciate it, why knowing the property would be important. And if you fall for a pitfall also, then once I show you this theory also, you'll be able to, appreciate it more, why these theories are important. So I'm going to show you the first question, give it a shot, and then I'm going to discuss the properties behind that question, and then finally I'm going to show you how you need to solve that particular question. Okay, so here's the question, first question in front of you guys, and let me bring up the poll. Okay, I've added the poll. Make sure that you answer, give your response in the poll only. Please do not put it in the chat box. I'm going to delete if you're going to do that. Okay, just letting you know now only. So you have about 2 minutes to do this. This is a pretty straightforward question. If you know the property, you'll be able to mark it. Those of you who know the property will be able to do it in 30 seconds, frankly. Those who don't, not knowing, or you might not be sure what to mark in this case. So far, the response has been pretty good. I'm happy with the accuracy so far, though it's dipping slightly now. Okay, another 10 seconds, guys, then I'm going to end the poll. So if there's anyone else who would want to, and I would encourage all of you to put in your response. It's okay even if you get it wrong, guys. In GMAT, I keep on reiterating that you have to mark an answer before you move on to the next one. So, get used to marking something at the end of each and every question. Okay, so 56% of you think that the answer should be C, and I have a few D's and E's. Surprisingly, I had hoped for a few more D's, but it's a good thing. It's a good thing that most of you ended up marking C as the answer. Now, let's come to the properties part. Now, see, this is a fairly straightforward question here, right? They're asking you whether the quadrilateral that you have is a square or not. And the information that has been given to you is an information of diagonals. Okay, so they're telling you something about the diagonals. Diagonals are either equal, and in this case, they're telling the diagonals bisect each other at 90 degrees. Now, if you notice, the question does not have anything to solve as such, right? If you know in which quadrilaterals the diagonals are equal, you will be able to figure out whether WXYZ is a square or not. And if you don't know, well, then as I told you, don't know. So what we usually do is, and this is kind of one of our, screenshot of our video lessons only, where ideally what I would want, and you can take a screenshot also. Let me just bring all this up very quickly on the screen. Yeah. So this is how I would request all of you to kind of, segregate the information about all the quadrilaterals in one place properly, so that you can compare the information and sequentially remember each and everything about each and every quadrilateral. One important thing which I want to point out here is that rectangles, squares, rhombus, these three basically, they are special type of parallelograms. So the first and the foremost thing is that you should be very well versed with the properties of a parallelogram, like knowing that the opposite sides are equal. So this length and this length are equal, this length and this length are equal, right? Now, the moment you know the side property of a parallelogram, you can build upon and then try and remember the properties of the side properties of the other quadrilaterals. Like, for example, from parallelogram to rectangle, I know the length property does not change. Here also still the opposite sides are equal. But when I come to square, all sides become equal. When I come to rhombus, all sides becomes equal. So learning it in a tabular form, in a sequential form, becomes really easy if you want to learn it like this way. And frankly, I prefer this way, especially when it comes to the property of diagonals, because GMAT knows most people falter in the diagonal property. The rest of the properties are quite distinctive, and it's easy for everybody, to remember it and solve it. But this is where most people falter. Now, what I want you to focus here is that in case of a parallelogram, the diagonals bisect each other. So if you join the diagonals like this, when I say they bisect each other, what I mean is that they cut each other equally. Okay, they'll cut each other equally, but they might not be equal. Okay, they might not be equal, and they do not bisect each other at 90 degrees. So this is the way we remember it. They bisect. They may not be equal. They do not bisect, and they do not bisect at 90 degrees. But when you come to rectangle, one of the properties changes. So they bisect each other, but now in the rectangle they are equal. These diagonals, both these diagonals are equal. Both length, so AC and BD both are equal. Okay, but still they do not bisect at 90 degrees. So the do not bisect at 90 degrees still does not change. So they are not bisecting it. Okay, but when you come to square, everything works now. They bisect each other, they are equal, and they even bisect at 90 degrees. So these two lengths are equal. These all lengths are equal, and this is 90 degree. Okay. So if you learn it like this progressively, missing out any property or any chances sometimes becomes reduces a lot. A slight change is in the case of rhombus, which is a slightly special case where the diagonals do bisect at 90 degree. Okay, but the diagonals are not equal. So this is equal to this. This is equal to this, but AC and BD are not equal. Okay, so just keep in mind AC and BD are not equal, but they bisect at 90 degree. So this is how you need to kind of remember these properties. So if you want, you can take a screenshot of this, take a printout and keep it to yourself and kind of revise it so that you don't make a mistake. But if once you know this property, you will be able to use it very quickly and figure out that the question is kind of testing you about rectangles, squares, and rhombuses, diagonal properties, nothing else. So in this question, when it's given that the diagonals are equal, okay, you can very quickly say, oh, is the diagonal equal? Then obviously it could be a rectangle or it could be a square. It could be both. Which one it is, I don't know. So this is not sufficient. See, it will hardly take you 10 seconds to answer this. Okay. When you come to this one, you'll say diagonals bisect each other at 90 degree. Okay, 90 degree bisection happens in two cases. Square, rhombus. Again, won't take a lot of time, but you'll be able to eliminate it very quickly saying not sufficient. Okay, now when you combine, you know that there's only one case where the diagonals are equal also and they bisect each other at 90 degree, and that's a square. So you can mark your answer as C. Mark that in 30 seconds, move on quickly. So I hope you understand, and I hope you appreciate the part that knowing the properties can really, especially for these questions, this is a 600 level question, not a very difficult one, but they can, if you don't know the property, you might miss out on a very easy question just because you didn't know which one bisect, which one doesn't. Okay, so please, it's a request that make sure that you learn all the properties really properly. So if this is perfectly clear, please mark yes so that I can move on to the next one. Karan, we don't know. If they're telling you the diagonals are equal, parallelogram, no, I will not say it can be a parallelogram because in parallelogram, I don't know whether diagonals are equal or not. So I will not say that WXYZ could be a parallelogram. I will not say that. If I know the diagonals are equal, then I can be sure that it is a rectangle or a square, but I cannot be sure that it is a parallelogram. So I will not include it in it. Okay. I hope that answers your query. Okay, great. So I can see it's clear to everyone. So let's increase the difficulty level a bit and move on to the next one. Okay, try this one, and I have added the poll. Again, you have 2.5 minutes to this one. Okay, I'm ending the poll now. Can anyone tell me in this question, what exactly is the trap? Most of you could have got this one correct, but I think you misread one thing. Can anyone tell me what's the trap in this question? A small trap. It's a fairly straightforward again question. It's between 650 to 700 level question, but the accuracy drops a bit in this case because of one smaller mistake that most of you might have ended up making a mistake. I'm saying so. I would want you to read the question carefully. Okay, so Deep says height is common. Height is common is a concept that we're going to use. Very good. Okay, so yeah, Nitin, that's absolutely correct. Very good. That is where some of you might end up making a mistake. Yeah, very good, Tia, and everybody. That is what I was looking for, and that is the reason I specifically give these kind of questions. That make sure that, and this is a tendency. I'm being very honest here. Even I have made these kind of mistakes. You look at the word quadrilateral, you look at the word PTS, and you end up thinking that the question is asking you about PTS by PQRS. You end up thinking that you're looking at the full parallelogram. However, if you look closely, the question is asking you the area of triangle PTS is what percent of the area of the quadrilateral QRST. So they are talking about this part of the quadrilateral, just this portion out here, nothing else. So not PQRS, but QRST. So and most of the people end up marking only these two answers. Obviously, one of them is correct, and the reason the people choose the incorrect one is only because they end up not reading this properly. So, guys, please, this is something like we are almost at the last leg of our webinars, and I've been reiterating this. Read properly. Don't assume anything at all. Make sure you double check that the quadrilateral that you're looking for is the one that is required. Now, after post that, the question is pretty simple, fairly simple. If you look at PTS, to find out the area of PTS, you just need to do half. You have to look at the base. The base in this case is PT, okay? And there's a height that you need to drop. Now, the good thing is that PQRS is a parallelogram. So I know these are, if you, usually what I do is I mark all these things. So if it's a parallelogram, I mark this. I mark this, these two lengths are equal. I mark these two lengths are equal. These are like common hygiene things which I definitely do every time, even if it's not useful. The second thing which I do obviously is, this I have discussed a bit in word problems also, that whenever I see a ratio like this, like I've been given a ratio that PT by TQ is 2:3. So I write it in terms of in terms of absolute value. So I would say let this be 2x. And I would say let this be 3x. How this helps me is that I know, okay, if this is 2x, 3x, I know that this portion out here, because it's a parallelogram, this length has to be 5x. Okay, because opposite lengths are equal. Now, once you do this, after that, the question is very easy. If you want to find out the area of the triangle, you need to drop a height here. Let me name it as, say, SW. So half PT by SW, that's what I'm looking for. Okay. And as far as QRST is concerned, if you notice QRST, and again, once again, you can look at the property. It's a trapezium. If you notice, it's a trapezium where these two lines are parallel. This is 3x, this is 5x, and obviously you need a height. Okay. Now, the main thing that you need to keep in mind is that since these are parallel lines, the height, whatever height you drop from S to P. If you drop from S on this line, or if you drop from here to here, doesn't matter. These heights, they are all the same. Between parallel lines, the perpendicular distance always remains constant. Okay, so whatever height you drop, they are all going to be the same, and that's one of the learning or the properties, that inferences that you need to draw to solve this question. So in case of a parallelogram, in case of a trapezium, okay, the formula is half times sum of parallel sides. Now the sum of the parallel sides is 5x, 3x, fairly simple. So you can write it as 5x plus 3x. In fact, let me even write PT as 2x because I already know this is 2x. Okay. I've already told you the height is going to remain the same. So the height is going to still be SW only, same perpendicular height. So at the end of the day, if you notice, you see everything is getting cancelled out. You're left with 2x by 8x, which is 1 by 4. So, and since you're looking for a percentage, you need to multiply it by 100 to get your answer. So the correct answer in this case is going to be 25%. Those of you who ended up marking the answer as 20%, you ended up doing this, which is, I hope now you understand what you did. You simply did base times height, and you, instead of doing 1 by 4, you ended up doing 2 by. So is this clear? If you have any questions, please feel free to ask. Let me bring up the yes and no poll quickly. Any doubts at all? Okay, I don't see any questions, which is good. Okay, perfect, great. Okay, so let's move on to the next one. Even this is a very interesting question. That's the formula. So the formula for the trapezium is, area of trapezium, let me write it down, is half into sum of parallel sides. Okay, that's the formula. So that is why I have to add into the height. Okay, so that's why I'm adding it up. Okay, so let's move in. So here's the poll for the next question, guys. And I'm going to end the poll. Once again, this is purely based on properties. If you know the property of a polygon, you'll be able to do it in about 30 seconds. And most of you, frankly, in this question have fallen for the trap. Most of you. Can anyone tell me what's a trap? I'm ending the poll now. 46% of you think that the answer should be A. I have about 23% who think C, fuse E also. But anyway, what do you think could be the trap in a fairly simple question like this? In a 650 level question, but the accuracy is slightly on the lower end. Okay, let me ask a more specific question. I think that will help. The first line of the question says, if all the sides of the polygon are equal, what is the meaning of this? The moment you read this, what triggered in your mind when you read this? All sides of the polygon are equal. Good, Kunal. Harsh, good. Jaya, kind of correct. Okay. No, Jaya, there's a small mistake, I would say. All sides are equal. Yeah. What do you infer from this? All sides are equal. Okay. Anubhav says regular, Shivam says regular, Yashwant says regular. Okay. Yeah, so that's the trap that I was talking about. Okay. Guys, can you tell me, can't you think of a figure where, all sides are equal, but it is not a regular. Okay. My bad, guys. Let me ask you a question. What's a regular polygon? What is a regular polygon? Can anyone tell me? What's the definition of a regular polygon? Okay, Tia says lengths and angles both should be equal for it to be a regular polygon. Good. So for a regular, and I want to emphasize on the word both here, guys, that length and angle both need to be equal for a polygon to be a regular polygon. Okay. Now, if somebody tells me, and I'm going to the next slide does have all the definitions, but I'm going to just add a few points here. Now, if I am just told all sides are equal, I'm just given this information. Okay, can I infer that I have a regular polygon with me? If not, why not? Can you give me an example of a polygon where all sides are equal and it is still not a regular polygon? I hope my question is clear. All sides are equal. Can I say it's a regular polygon? If no, then very good. I know that's correct. No, we cannot say it's a regular polygon. And the example, very good. Exactly. So rhombus is a good example where you know that all lengths are equal in a rhombus, but all angles are not equal. Opposite angles are equal in this case. Okay. Similarly, if I'm given all angles are equal, this information is given. Can I infer that it is a regular polygon? Can I do that? If not, why? Can you give me an example where all angles are equal, yet it is not a regular polygon? That's a very example, a very simple example, right? The easiest example is a rectangle where all angles are 90 degree. All four angles are 90 degree, but it's not a regular polygon. So the learning that you need to keep in mind is that if you're given partial information, okay, just partial information that all sides are equal or all angles are equal, please do not infer that they're regular polygons. Okay, only if you're given both the information, only if you're told all sides, all angles are equal, then only you should go and infer that it is a regular polygon. So that is something that I've kind of written out here, that regular polygons, in case of regular polygons, all sides should be equal and all angles should be equal. And obviously, there are a lot of examples you already know. There's an equilateral triangle, squares, regular point, and these are all regulars. Okay, just partial information. Do not infer anything at all if you just know one portion of it. Okay. Apart from this, and this is a side topic, again, this is not related to the question, but you should ideally know the formula of finding out the total internal angle. And I'm writing that first. The total internal angle, and this is for any general polygon, okay? Like regular, non-regular does not matter, is n minus 2 times 180. This is one formula that you should know. And you should also know that the total external angle for any regular polygon is 360. Total. Keep in mind, I'm using the word total again, total internal, total external. So if you want to find out total internal angle of, say, a pentagon, you just put 5 here, 5 minus 2 times 180, and you'll be able to figure out what is the total internal angle. Okay. Now, in case of a regular, in regular, we know that all angles are equal also. So if you want to find out the value of each angle, if you're interested in that, then what you can do is whatever formula that you have, n minus 2 times 180, you simply divide it by n, obviously, and that's very logical, right? If you know the total angle, you just need to distribute it equally. So divide by n, and you'll be able to figure out what is the total, what is regular polygon interior, or this would be exterior, my bad, each exterior angle of a regular polygon. Okay, so these are the basic information that you should definitely know to be able to solve questions based on polygons. Okay, now as far as this question is concerned, it's pretty simple. All sides are equal. You'll say, okay, I don't know what to do with this. I need to find out how many sides does it have. Okay, so I need to find the number of sides. Fine. First statement is each P has P has an external angle. So whatever that polygon, you don't know what kind of a polygon it is. Could be a pentagon, decagon, nonagon. You don't know, but you know just any one of the angles somewhere, some angle is 60 degree. Okay, but you don't know what are the other angles. What angles are these? You have no clue what kind of angles that you're dealing with. Since you don't know that, you also don't know whether it is a regular polygon or not. And I'm saying just based on what the question stem and statement want. You don't know anything. Since you don't know whether it's a regular polygon or not, just knowing that one of the external angle is 60 degree is useless. So you will say this is not sufficient. Okay, fairly simple, quick that you can do it. Second statement tells you all internal angles are equal. Now notice, you know all interior angles are equal. From the question stem, you know all sides are also equal. Now, once you have these two information, and I'm just talking about statement 2, by the way, okay, statement 1 is gone. From statement 2 and the question stem, you can infer that this is a regular polygon. But again, just knowing it's a regular polygon and having no information about anything else, obviously cannot help you get your answer. So you will say even statement 2 is not sufficient. Now, when you combine, you have two information. You know it's a regular, and you also know that an external angle is 60 degree. Now, since it's an external angle and it's a regular one, each external angle will be the same. So now if you want, you can use the formula 360 by n is equal to 60, and then find out the number of sides. Okay. So I hope it's clear. This is again a very common kind of mistake. So I wanted to make sure that you understand this properly. If you have any doubts, please let me know. Please ask questions. And if this is perfectly clear, then please mark yes. Okay, great. I can see it's clear to everyone, which is good. Guys, great. So now, guys, let's increase the difficulty level a bit more. In fact, this is, yeah, try out this one quickly. I can still see a few of you saying no. If there's any doubt, please ask. Please feel free to ask in the chat box. So Sudeep, the formula is valid. There are two formulas I showed you. The total angle formula is valid for any polygon. Okay, so the formula which I gave you, n minus 2 into 180, and the 360 external and internal formula, this is valid for any polygon. Okay, just keep this in mind. Segregate the information this way, any polygon. If you're dealing with a regular one, then what you can do is you can find out about each angle also. So if you want to find about each internal, then you take this formula, what you have given out here, and then divide that by n. If you want to find each external, then you divide this by n. That's all. Okay. We have written it down. Please let me know if you want me to reiterate anything else. Yes, Jay, it's being recorded. Don't worry. Most of you, I think, have got the correct answer in this one. Okay, I'm ending the poll now. Okay, so 68% of you think the answer should be B in this case, which I think it is. So let's very quickly discuss the property of a regular hexagon. Regular hexagon, when it comes to regular polygons, the favorite one, apart from the quadrilaterals and the circles, is quadrilaterals and the triangles, is the regular hexagon. That is what they like to test students a lot, GMAT. So in this, what you need to kind of understand, only the one major property, if you understand properly in this regular hexagon, most of the work becomes really easy. Now, as far as formula is concerned, if I look at the formula, n minus times 2 minus 180, and if I put n equal to 6, I get this, right? This is my total internal angle. And if I want to find out the value of each internal angle, I kind of simply divide it by 6, which gives me 120. And this is, I would say, it's better if you can remember it, okay, because this is going to be used very frequently in case of a regular hexagon. So I would want you to remember 120 in case if you want, in fact, even if you can remember for a regular pentagon also, that's good. If you're not, there's no pressure as such, but for a regular hexagon, I would definitely want you to, not solve it every time. Okay. Now, apart from this 120, now what happens is that if you join all these lines, okay, if you join all these lines, then what happens is that all of these angles get split equally. Okay, all the angles that you see out here, they split, obviously they're all equal. And since you had a 120, they get split into 60 each. Okay, and I hope now you can see and visualize that what's happening out here is that at the end of the day, you end up getting 6 equilateral triangles. Because if these two are 60, then obviously this is 60, this is 60, this is 60. All of these end up being 60. So if this length is, say, X or A or whatever you want to call it, and if you want to find out the area of the regular hexagon, all you have to do is just find out the area of any one triangle. Any one triangle, just find it. And obviously there are 6 of them, 1, 2, 3, 4, 5, 6. So you just multiply it by 6. So 6 times area of the equilateral triangle would give you the area of the hexagon. A very simple formula, a very basic one, and I would again recommend that you remember these. When it comes to area of shaded region also, it becomes really easy. The moment you understand that you're dealing with 6 equilateral triangles, you can kind of split and figure out which ones you need, which ones you don't need. So in this case, if you look at the diagram, and one more important thing, by the way, since these are 6 equilateral triangles, all these lengths are the same. Just keep in mind. It's very intuitive also, but I just want to make it really dummy proof, make sure that everybody understands it properly, that all of these are A. They're all equilateral triangle, all will have the length A, each length is the same. Now, why is this important is because in this case, see, they are telling me that the length of the diagonal is 8. AD is 8. So if AD is 8, and I've already shown you, see, this is 8, this length out here. This is 8. This is 2A basically, twice of anything. So if I want to find out this length, I can say this is 8, this is 4, this is 4. All these lengths out here, they are all equal to 4. That is all you need to do. And then if you want to find out the area of the shaded region, you can see there I'm talking about 4 equilateral triangles. Okay, so all I have to do is write 4 times root 3 by 4 into 4 square. That's it, and I have my answer. So you can see, if you remember this property, visualize properly, this will hardly take you 1.5 minutes to solve the question. So you get a 650 level question correct in 1.5 minutes without any problem. Okay, so I hope whatever question that you have discussed so far, from now on, the question that I'm going to be discussing will be more based on visualization. But I hope so far the questions where I'm showing you why the knowing properties is important is absolutely clear to you. Dhruv is asking, why does it split equally? What if the diagonals do not enter? Vihar, Dhruv, see, it's a regular polygon. So what happens is that the central angle becomes 60 degree. Think of it in this way, that all these diagonals will have to pass through the center only. They'll all pass through a single point by symmetry. And what happens is, in case of a regular polygon, that these angles get equally split. So these are all, the center would be equidistant from each point. So think of it in this way. It's not going to happen that you have a regular polygon where the center is skewed. You're not going to have a center like this in a regular polygon. To think of it in this way, you cannot have a center here where you join. This is unsymmetrical. That's not going to happen. Just to let you know, it's a symmetrical figure because of which at the center, the whole central angle that you have will get divided into this whole central angle is 360, right? And since once you join all the diagonals, they equally get split into 60 each. Okay, so by symmetry, they'll get equally split. And since the center is from the center, all the points are equidistant, right? Because it's a regular hexagon. So all these points are at the same level from the center, which means that all these lengths become equal. Now, the moment all these lengths become equal, the central angle is 60, and these two lengths are equal, they have to get equally split into 60. Okay, so I hope that answers your query. Okay, Danish is asking, how did you get root 3 by 4? Okay, Danish, the formula for a equilateral triangle, area of equilateral triangle is this only, root 3 by 4 times the side square. Okay, that's the formula for area of equilateral triangle. Now, in this question that you have here, you are dealing with shaded region. Look at the shaded region. You have 4 triangles. And in the previous slide, I showed you that all these triangles are equilateral triangles. Okay, so if I have 4 triangles, all are equilateral triangles. So that is why I have to do 4 times area of equilateral triangle. Area of equilateral triangle is root 3 by 4 times the side square. Okay, so I hope that answers your query. Any other doubts, anyone? Okay, Janani is asking, can you please repeat most commonly asked? It's very difficult to tell you. It doesn't matter if it's a DS or PS as long as it says it's a regular hexagon. Okay, the key thing here is regular. If the word regular would have been missing, then obviously all this discussion that we are having is futile. We will not be able to do anything at all. As far as your question is concerned, in case of a regular hexagon, you will usually get you'll usually be asked to find out the area of some part of the shaded region or the other. Okay, so in this case, I gave you 4 equilateral triangle. Sometimes they do even give this. In fact, let me see if I'll be able to draw it here. They might give you, draw something like this, and they might ask you, hey, find me the area of this shaded region. So most of the questions are kind of based around shaded regions only. So they're kind of asking you half of the hexagon like this. They might ask you, they might give you from central this part, and they might ask you find the area of this shaded region. So questions based on regular hexagon, if it is based on area, would be some part or the other of the shaded region. So as long as you are clear with the 6 equilateral part, you'll always be you can always use the central part to find out the whatever shaded region they ask you. So if they ask me about these 2 parts, I know I need to discuss these 2 triangles and find the rest of the area. That's it, nothing else. Okay. So Vihar, Janani, Chanel, I hope I have answered all your query. Naseem, what you can ask questions. You don't need to, just let me know whatever question that you have. Sudeep, this is a 650 level question. So just reiterating again, please keep in mind that in case of a regular polygon, the center would already be equidistant from all the points. It's not only about hexagon, it's about any figure. Okay, the center would always be equidistant from all the points. So even if you have a pentagon or a nonagon or whatever, they won't ask you about nonagon, decagons, don't worry, but they'll always be this central point will always be at the same distance. The central point will always be at the same distance from each of the extreme points. But keep in mind, I'm talking about regular always. They will never ask you generic questions on hexagon where I haven't seen any, in fact, generic questions based on regular hexagons at all. Okay. So I don't see any more questions on the chat box. So let's move on to the next. Okay. Sudeep, you should be able to see it because I can see all the questions that are being posted are all public chats, so you should be able to see it. Shinal, the question that you're asking is out of scope at this point of time. I cannot, sit and derive the area of equilateral triangle. Ideally, I would recommend learning the area of the equilateral triangle formula instead of deriving it. Pooja, unfortunately, we don't share PDFs of the session. We only share the recording, and that recording would be uploaded on our YouTube channel. But PDFs we don't share. And just for the sake of clarification, you don't need to know the derivation of any of the formulas. Okay, it's not only about equilateral triangle, but any of the the formulas that you're learning. If you want to, you can. That's not a problem. For the sake of knowledge, I would never say stop learning those things. But from GMAT perspective, you were never going to be asked questions on that. Okay, so don't worry about it. Okay, guys. So I'm showing you the next question. I hope you're able to see it, and I've added the poll also for the next one. Just in case if you still have any questions, please feel free to ask regarding the previous one. I'll type in and respond to your queries. Okay, the answers are kind of scattered all over the place. So I'm ending the poll now, and then let's start the discussion. Can anyone tell me what's the property that is being used in this question? What property should we use to figure out the perimeter? I've been given an angle, 100 degrees. Center is O. The diameters have been marked. So how do I use the angle information to figure out the perimeter of SPRQ? Okay, central angle, area of angle of this sector. Good. Area of the circle. Yeah, we have to use the formula of the circle, but more specifically, we have to use the sector. Okay, so let's come to the part of angle separated at the center is twice that of the circle. Yeah, very good. So that's the property that we are going to use in this case. So let me just very quickly go through the property. In this property, there's one catch. That is why I wanted to discuss a small scenario to help you out with it. So the property is very simple. Okay, it simply says that, okay, from say 2 points, if you draw something at the circumference, okay, then from the same 2 points, if you join the center, then the angle at the center would be double of that of the circumference. Okay, simple rule. Let's say if the point is x comma y, from x, let's not take x comma y, let me take AB. So from AB, you went and you drew an angle C, this x. From the same point AB, if you notice, if I take it to the center, you get 2x. That's all. Okay. Now the catch here is that most of us are used to seeing this diagram only. So we are used to always drawing like this, theta x 2x, and we are kind of comfortable with it. But nobody talks about a scenario like this. Okay, where this is x. Okay, looks the same by the way, but in this case, when I join these 2 points and take it to the center. Okay, the diagram, as you can see, looks slightly different now. Okay, now some people end up taking this as 2x, which is incorrect. Keep in mind, if this is x, you always take the angle which is one opposite to it, like just the same facing the same direction. By the way, that's the easy way to understand. If you're taking this as x, then this angle at the center is going to be 2x. Okay. Don't take this one as 2x. That's all I wanted to say. This would be wrong. Is this part clear, everyone? Let me place a no poll quickly. So these two visualizations should be pretty much clear to you whenever you're solving a central angle question. And this is what this question that we have here is also based on. So if you notice, what I'll do is I'll kind of, try a crude diagram, slightly difficult, but I'll try my best. Drawing a circle is always difficult. But let's say this is it, okay? And I'm going to, kind of rotate the diagram a bit. I'm going to put T here so that it's easy to look at, okay? So T, Q, S, and O. I'm just taking this much, okay? I know there's a P here also and an R. I'm not drawing it. I'm just marking those points here, but I'm not extending them, okay? I'm just keeping it there. This is it, and this is 100 degrees. This is what have been given to us, okay? Now, what else is given to us? It's given that RS, that is the RS, this whole thing, the diameter is 36. So I know this is 18, this is 18. All this is 18. Okay, so let me mark that also. This is 18, this is 18. This length, SONOR, okay? Another important thing which I want to emphasize on is the word the perimeter. I am looking for the perimeter of the sector. So whenever they talk about sector, okay, let me go to the previous diagram. This is what you call a sector, okay? This is a sector. When you talk about sector, this is the sector. The whole thing is called the sector, okay? When I talk about the perimeter, when I use the word perimeter, what I'm basically looking for, if I just draw the diagram, I'm looking for the sum of all these lengths. Okay. Now, if you visualize properly, if you look at properly, if I say perimeter of sector, I'm looking for all these three lengths. And this is the center. Let's say name it as O. So this length OB, this length OA, these are the radiuses, right? This is R, this is R, this is the radius. Okay. R, R. This part, the part that has been highlighted with red, if you can see properly, this is AB. This is the arc. And the length of the arc, if you're not aware of the formula, is basically theta. When I say theta, I mean the angle out here, okay? Whatever be the angle out here, divided by 360, multiplied by 2 times pi times r. Okay, so if you want to find out the length of the arc or the length of the curved part in simple language, then you have to figure out how much is this angle. So in this case, if this is 2x, so you'll write it as 2x upon 360 multiplied by 2 pi r, and you'll get the length of the curved part or the arc, whatever you want to call it. So if you want to find out the perimeter, you'll have to add up all the lengths, r, and the length of the r. So the total perimeter would be 2r plus theta by 360 times 2 pi r. Okay, so this is another learning that you should be very much clear with. If they ask you only about length of arc, I'm reiterating it again. Length of arc is simply theta by 360 into 2 pi r. If they ask about perimeter, make sure to add the radiuses also to this. Okay, so in this case, I've been asked the perimeter of S, P, R, Q. So I'm talking about the whole thing. So if I have to, again, I'm doing all this just to make sure that you understand, visualize it properly. So they are asking me to find out the perimeter of this whole thing. Okay, this whole diagram. Now notice what is involved in it. SO plus OR. These are the radiuses. So 18 plus 18. Okay, plus I need to find out the length of the curved part now. So to find out the length of the curved part, I need the angle. And this is where again the theta 2 theta comes into picture. So notice I'm now talking about this diagram. It almost looks like this. Notice this is 100. I need to find out the angle at the center. So this angle will turn out to be double 200. So this is 200. So I have to do, let me use some more space, 18 plus 18 plus 200 theta. I'm using this formula now, by 360 multiplied by 2 pi, and the radius is 18. Okay, so I hope this is perfectly clear, and you can see the answer obviously is going to be, this is 36. You cancel this out, you cancel this out, you cancel this out, and then you end up getting 20 pi. So the correct answer in this case is going to be option. Okay, so I hope this is clear. If you have any questions, please feel free to ask. Let me look at the chat box once. I've been talking for a long time. But if there are any questions, guys, please ask. So again, this is a question where I was talking about, I told you now we are doing questions where visualization is important. If you're not able to visualize properly, there's a good chance that you might not be able to see this 100, 200 properly, and may end up taking 100 only. These kind of small minor mistakes, or you might even miss out the word perimeter to make it a mistake. That's always the center above I just showed you, right? If from the circumference, from the point SQ, these 2 points, on the circumference, I'm drawing the angle as 100. This angle is 100. Okay, so on the center, if I again to visualize it, to show it to you, this is on the circumference 100. So if I join it on the center, O is the center, please keep in mind. The angle at the center would be double of it. It's 200. Okay, so I hope now you're able to visualize it. That's okay, Sudeep, that's okay. As long as the concept is clear, that's good. Make sure that, you know, these, if you can avoid these small things, that would be great. So these, I know some people end up making these small mistakes, arc, sector. So just wanted to clarify this 100% so that you don't make these mistakes again. Okay, great. I don't see any more questions. Everyone's saying yes, which is perfect. Absolutely good. Okay, now let's go to our, I think this is the fifth one, right? Okay, so again, I'm reiterating something which I've already told you, that in geometry you have to make sure that, you know, this, especially the question that I showed you, you might even know the concept, you might know theta to theta, but if you're not able to visualize properly, you will end up making a mistake. So if you want to, you know, make sure that you follow these processes properly, and I've told you this, that we are already showing you all these things in our booster files very, very properly. So those of your students who are especially, you know, starting off geometry or will be doing geometry, make sure that you follow these methodologies properly. Go through the way I'm solving these kind of questions when you're looking at the booster files, especially, so that you don't make such kind of mistakes. Okay, those of you are not our students, and if you're still interested in learning all of these, obviously these webinars, free webinars are there. But if you're interested in going, you know, learn more in depth, and there are a lot of other things which we are not able to discuss, right, because of the limited constraints and the time that we have. Then apart from the course, I think Piyush must have already told you, and I'm also letting you know that we are starting our crash courses. So if anybody's, and this is starting from the 24th, so if there's anyone who's still, you know, you're starting a prep and you want to work with us, have these kind of sessions, more in detail sessions, because these are short sessions. The session that you're going to conduct would be more exhaustive, more complemented to the lessons that you are learning from the course. So if you're interested in joining our crash courses, there we are starting one on the 24th of April. So if you want to know more about it, please feel free to get in touch with us. Okay. So this is just a minor information from my end. There are two more questions I want to discuss. One of them is a really good one, and this is the one that I was talking about in the starting also, where I'm going to show you what approach usually you need to, in general, and I'm going to generalize it as much as possible, to solve any geometry question. What are the things that you need to see? What are the things that you need to mark? All of this is being captured in this particular question. So it's a very good one. I'm going to give you about 3 minutes to do this one. This is slightly difficult. So take your time, and then let's discuss after 3 minutes. Okay. Okay, so those who are done, tell me, what do you think of this question? Was this difficult, easy? I know I've already told you it's slightly difficult, but some of you answered this fairly quickly. So what's your take on this question? In fact, let me end the poll now. 50% of you think that the answer should be C. And about 34% of you got the answer from B. So now that you have the result in front of you, you can see what people have marked. What do you think? Okay, Anubhav says seems to be easy, medium. Okay. What about the others? Okay. Frankly, the accuracy of this question is just 7%, by the way. Most of you got this one incorrect. So at a glance, it might seem easy for some of you, but it's not. In fact, I won't say it's not easy. What makes this difficult is the way you assimilate all the information that is given in the question. Now, let me tell you how I approach it, and not only this question, by the way, in general. Okay, any question, whenever I see a geometry question, the first thing which I do is mark all the information. Okay, however trivial that might be in the diagram. Okay, it might be a very minor information, like, you know, it's a center, so the lengths are equal, and in most of the cases, people keep this information in their mind, and I would strongly recommend not doing it. So what you should do is that when you see a diagram like this, you know O is the center, right? So you mark all the radiuses that you know are going to be equal. Okay, so In this case, I'll mark it something like this. Okay, OP, OQ, OR. If you want to name this little thing also something, you can, up to you, like OW. And if you want to say, okay, this from here to here, this length is equal, definitely do it. Make sure you do it. Once you do that, after that you should try and see, because most of the questions that you'll get in circles would be a mix of, a triangle or a quadrilateral or something like that. So the moment you mark these lengths, what happens is that it kind of triggers, and it should trigger with a lot of practice, that you should be able to see that you are dealing with isosceles triangle. And since I'm talking about this, I would want to emphasize in most of the in the questions of circles now, you will notice these kind of structures like this structure, diagrams which will look something like this, or sometimes and variations of this, basically in any shape sizes they might keep on giving you. What you need to kind of do is understand that the moment you are using the center and the end points, it should be a trigger for you that you're dealing with an isosceles triangle. That is one small minor point which I want to add here. So circles plus triangles, there is a very good chance that you might be dealing with an isosceles or an equilateral triangle. So if you may want to make a note of it, so that in the exam when you're solving question, you can start thinking along those lines. So in this case also, the moment you draw this, you'll start noticing that there are a lot of isosceles triangles in this diagram. In fact, two of them should be very quickly, you should be able to see. Now, how does that help? It helps because now you can mark even more things. In isosceles triangle, you know the opposite angles are equal, right? These two angles are equal. So you know if this is 48, then you can mark this also as 48, right? So these two would become 48, 48. Second thing is, which again a lot of people don't do, a lot of students don't do, is that they again keep this in mind that, okay, it's an isosceles triangle, so the angles are equal, but they don't write something. Like for example, a variable A or a variable B or X or Y. Don't do that. Please do it. I would request you to do it, because see, if you're trying to find out an answer, if you're trying to find out, like in this case, if I go back a bit, what are we looking for? You're looking for an angle, right? You're looking for ROS. So to find that out, you would have to set up an equation. Some equation you may have to, I won't say have, but you may have to set up an equation. Okay, so if there's a slight chance to set an equation and you're not taking any variable as such, then what equation will you try and create? You won't be able to create anything, right? So the second thing which you should do is that if you see that there could be other angles equal, mark them as something. Okay, so you can mark these as X and X. Apart from that, obviously, you cannot mark anything else. As far as marking is concerned, you can do a few more things, which I'll show you in the next slide. Okay, but once you're done with the obvious things, then you start thinking, okay, what next? What else can I use to find out about the other angles? Because there's still this angle, there is this still angle, there is this still angle, this angle, this angle. Can I do anything about these angles? Okay, and you won't be able to do it unless until you mark something. That's point number 2. And once you start thinking along these lines, that what should I do with these angles, you start thinking along the properties, because now you're dealing with a triangle. Circle wise, you cannot use anything else. There's no circle property that can be applied anymore, right? So you would reason yourself and say, okay, I cannot do any more circle properties, angle properties. So what other angle properties can I use? Because the question is talking about angles. And then you should start sequentially looking for these kind of angle properties one by one, because something or the other, especially I'm telling you, these two are used a lot. External, straight are used a lot. Even if you're not using external, if you're using straight and the first n3 or the 1 2 or 1 3, you will be able to figure out some relation between each and every angle that is present in the question, most of the cases. Or these angles will definitely help you set up an equation or some relation between the angles. Okay, so I'm reiterating the process in general. So whenever your step 1 should be marking all obvious information, and I'm specifying the word obvious here because people don't. Please do it. Okay. Second, then you try and apply property. Then you use the properties which you can. If you're dealing with triangles, then apply triangle properties. As I told you, in circles, isosceles are used. If, for example, if you're given a circle with a square, these kind of figures are also very common kind of figures, then you should start applying the properties of square. So I'll start doing a square or rectangle, whatever. So I'll start marking the obvious things like this, 90, 90, 90. I would mark this and say this is the diameter, and these kind of things. Basically, I'll start doing it. Once I'm done with this, then I would move to the final thing and ask myself, okay, what other angle properties have I not used, which are related to either the circle or the square, or if you're dealing with a triangle, then with the triangle. And then think only along those properties that are present in the question. And these I'm talking about difficult questions. If you're able to do this, it should not be a problem. Okay. Okay, let me look at the chat. I can see a few things. Yes, so Karan is saying one major issue I find in such geometry DS question with elaborate diagrams that you have to, there's no other option, okay? You have to, you cannot use the same diagram again and again. I don't. And one more thing, I've said this before also, and I'm saying it again. In difficult questions, you will take more than 2.5, 3 minutes to do the question. Okay, it is in the actual mock also. Whenever we take mocks, exams, anything, we don't do all questions within 2 minutes. So if I'm doing this question, and this is a difficult one, then I know I might end up taking 3.5 minutes to do this question. But if I'm following the process, then spending those 3.5 minutes would give me a correct answer. Okay, and a 700 plus level question, if you get it correct, then the chances of getting a higher score increases a lot. So don't, compromise on drawing the diagram in such cases. Don't try to improvise or use the same diagram again. And especially if you know you're making a mistake, then why do you do it? Don't do it. Please believe me, we don't use the same diagram at all. Second thing is, if you follow the process continuously again and again, the speed does improve a lot. Like the process that I'm telling you, for us now, it's very intuitive. So we start the moment we start reading the question, we start parallelly drawing the diagram and marking the stuff simultaneously. Some people waste time, especially in geometry and word problem, by not doing this. I've seen people solving word problem questions also by reading it first and then rereading again for second time to draw the diagram, set up the equation. Those are all bad practices. So if I'm doing a geometry question, I'll simultaneously draw the diagram, keep on marking things that are there. If I have to draw it twice for statement 2, I'll definitely do it. Okay. Okay, so now coming back to the question. So so whatever steps that I've told you here, I'm going to again very quickly put it in the diagram once again. So as I told you, I'll mark this as equal. I'll mark this as 48. Okay, I know these two are equal, so I'll mark this as X. I'll mark this as X. Okay. Now, here if you notice 48, 48, 96 already done. Now, as I told you, I'm going to step 3 now. I have a triangle. QOP is a triangle. So what I can do is I can say that this angle has to be 84, right? Because 48 plus 48 plus angle QOP should be equal to 180 degrees. Now notice I'm using total internal angle formula of a triangle. So from here, I'll be able to figure out the value of this angle. Okay, well and good. Okay, now notice this is X, this is X. So again, using total internal angle formula, I can say that this particular length out here is going to be 180 minus 2x, right? X 180 minus 2x. So again, I have used total internal angle formula to find out 180 minus 2x. Okay. What else can I use? I haven't used, notice that this is a straight line. Notice this is a straight line. So angle ROS plus 180 minus 2x plus 84. This should be equal to 180 because this is a straight line angle. A straight line has to be 180. So notice I'm again using properties very quickly to figure out that angle ROS is 2x minus 84. So this is 2x minus 84. Okay. Now only this angle is left. I haven't used this angle. Notice this is X. Okay. And I'm drawing this part separately, okay, so that you can visualize it. This angle is X. This is 2x minus 84. Notice this X is the external angle of this triangle. X is the external angle of triangle ROS. And I know external angle X would be equal to sum of opposite internal angles. So this should be equal to RSO plus angle ROS. So from here I can figure out RSO is 84 minus X. So this angle is 84 minus X. Okay, please let me know if this is clear or not. I can even find out this angle. This is a straight line angle. So I can say this is 180 minus X if I want to. So notice all angle that is there has been marked in terms of X. There's nothing in the, no angle that is left for me to find out. Please let me know if this part is clear. If this is clear, then the question is fairly easy. After that, we don't have to do a lot. So I'll come to the statement individually very quickly. So if there are any doubts, feel free to ask. Okay, so see, I'll spend time here. I might even end up spending 1.5 minutes here. Good chance of spending 1.5 minutes just writing these down. Not a problem. But after that, see, when I go to the statement, what's going to happen? Statement 1. SR is equal to OQ. Okay, SR OQ. What is OQ? OQ is my radius. Okay, OQ is the radius, remember? And if SR is equal to OQ, then if you look at this triangle RSO, let me again, if you want me to show it separately, look at ROS, SR, OR, where all radius is right. And notice this is an isosceles triangle now. If these two lengths are equal, the lengths that I'm showing out here, if these two are equal, then these two angles must also be equal. Okay, so I can say 84 minus X is equal to 2X minus 84. I can find X. No need to solve. I just need to infer. Once I have X, what do I need to find out? I need to find out ROS. What is ROS? ROS is 2X minus 84. I can plug my value here and get my answer. Done. How much time did it take? It didn't take much time, right? Because I have everything in my diagram. Statement 2 is RSO is 28. So RSO. So they are telling me the 84 minus X is 28. Again, I can find X. Once I have X, I can find out 2X minus 84. I can get ROS. So statement 1 is sufficient. Statement 2 is sufficient. So the correct answer is option D. So as you can see, the tough part is the visualization part. The tough part is the process part. If you can force yourself to practice and get used to the process of writing these things down properly, you can solve these questions fairly quickly. Thankfully, in this case, I did not have to redraw the diagram because all my angles were in the same variable. So I could very easily use the same diagram. But even if I have to draw it again, I wouldn't mind drawing it as long as I know what I'm marking. Okay, so I hope the process is clear now, guys, and there are no more doubts. Okay, I can see everyone saying yes, which is perfect. Good. So let's come to the last question of the day, guys. And that is going to be this one. That's good, Anubhav. If you're able to do it, that's pretty good. That's not a problem. Okay, guys, I've added the poll also. And I'm going to give you, again, this is pure play visualization based. So I'll give you 2 minutes, but there's no calculation as such. So take your time, try to draw the diagrams, and then let's discuss. Rohan, the videos do get recorded. I'm sharing the YouTube link again for everyone. The recordings get uploaded on this channel, YouTube channel. I would request you to, kind of subscribe to it. The moment we upload it, you will get a notification. In the playlist, look for countdown to round 1. All the recordings, old ones, the ones that we conducted in this series, and the ones that we are doing now will be uploaded here only. Okay. The accuracy for this one is fairly decent, I would say. About 40% of you got the correct answer in this one. Whether B is the correct or the C is the correct one, I'll talk about it while discussing the solution. But it's good to see the accuracy of this slightly difficult question to be correct, to be close to 40. So what I'm going to do is I'm going to talk about a few things regarding the sign. The question, I'll read it once just to give you the major important informations. So there are 2 lines, very simple, LMM and they are meeting at a point n comma 1 where n is greater than 0. So what's the significance of this information? Can anyone tell me? When I say they meet each other at n comma 1 when n is greater than 0, how does this help me? What does this tell me? Two lines, they are meeting at n comma 1 where n is greater than 0. So n is a positive number, which means that quadrant. Good, yes. So it tells me that they are meeting in the first quadrant. Both x and y are positive. Very good. That's good. Great. And the other important information that is given is that they both have the same sign. So when they say they both have the same sign, then that they could be both positive, both negative. The signs are the same as far as the slopes are concerned. And I need to figure out whether the slope of L is greater than M or not. Okay. That's a fairly simple question. Okay. Now, when it comes to slope and the signs, okay, when the slopes are positive, you should be able to know how they look when you draw it on the diagram. So if they are meeting in the first quadrant, okay, and both the slopes are positive, then the angle has to be less than 90 degree. Okay, so it has to look something like this. Okay. And in this case, as you can see, and I've written this randomly, okay, L and M, I'm just taking a hypothetical scenario to show it to you. So if you draw something like this, the one with a greater angle, so in this case, if you notice, this angle is greater than this angle. If you're wondering why, you can use the property of a triangle also and see that this angle is actually the external angle of this triangle. It's an external angle of this particular triangle. If you visualize it like this, this is an external angle, the one that I'm showing you here, and this is the internal angle, the one that you're showing here. So if the angle is more in this case, like this, if L and M look something like this, then I will be able to infer that the slope of L would be greater than the slope of M. Okay, so if both are positive, keep in mind angle has to be less than 90 degree, and the diagram should look something like this, where L, the line L should have the angle which is the external one. Okay. If the lines are negative, okay, then the angle has to be more than 90 degree. And when I say angle, by the way, keep in mind that whenever we draw the angle, no, the angle is drawn in the anti-clockwise in the anti-clockwise direction. Let me go back once a bit to scenario one. So notice I was drawing the angle like this. Okay, I wasn't taking the angle like this. I wasn't moving clockwise. Okay, whenever we take the quadrant, we draw a line. If we want the angle, we'll take it from the anti-clockwise side. Okay, so that's an important thing that you need to keep in mind. So whenever I draw a negative slope, when I say more than 90 degree, I mean it like this. Here also the logic is still the same, more the angle, more the slope. So once again, notice this angle is still the external angle. Okay, this is more than this one. And this is your line L. So I'll be able to say that slope of line L would be greater than slope of line M. So as long as you're able to understand what are positive slopes, how do you draw it, and which angle after intersection would make, which line will have a greater slope, you will be able to solve this question fairly easily without any problems. Okay, and let's look at how. So I know that they're intersecting in the first quadrant. And the first statement says that the x-intercept, now the x-intercept is the point at which obviously the lines are cutting the x-axis. So the x-intercept for L and M both are positive. So you draw two lines in such a way that they are cutting at the positive side of the x-axis, something like this. So these are the two lines. And notice I'm not marking L, M anything here. I've just drawn two lines. I know that out of these two lines, all the condition that is given is satisfied. Both have the same sign, both are positive, and both are meeting in the first quadrant. This is n comma 1. But I don't know which one is L, which one is M. I have no clue. That is not given. No information about that is given. So this could be L, this could be M. In this case, slope of L would be greater than slope of M. But it could be opposite also, right? I don't have information which tells me which one is L, which one is M. So since I don't have that information, I cannot figure out whose slope is greater. That's why this statement would be not sufficient. Okay. So I'm pausing here for a moment. Please let me know if this part is clear or not. Let me bring up the yes and no poll. If this is clear, please mark yes, and then I'll go to the second statement quickly. Good. So I can see it's clear to everyone. Good. So second statement is an interesting one, and I've drawn both the diagrams directly. So in the second one, they're telling me y-intercept of L is less than M. Okay. Now in this statement, I'm just talking about statement 2, by the way. Okay, forget statement 1. You don't have this anymore. When I'm dealing with statement 2, the information that I have is that they have to meet in the first quadrant. Okay, that's the first thing. They should have the same sign, so both positive or both negative. Okay, and the y-intercept should be less. So obviously I'll have to consider scenarios where both the slopes are positive. So this is the diagram, case 1, where I've ensured that they are positive and I've ensured they have the same sign. Okay, meeting in the first quadrant. And the y-intercept of L should be less. So notice the blue line, the y-intercept is here. This is line L. Okay, line L y-intercept. And this is the y-intercept of line M. So this condition is also being satisfied for case 1. And in case 1, when all the conditions are satisfied, notice line L has a greater angle. This is the angle that line L has. Since this is a greater angle, so for case 1, I can say slope of L is greater than slope of M. Okay. But don't pause here. Please keep in mind, those of you just did this and ended up marking the answer, you might have got lucky. Make sure that you consider both the cases. Consider case 2 also, where the slope is negative. Make sure the slope are negative, because I don't know what the slope would be. Make sure that they're in the first quadrant. And then again, make sure that you satisfy the condition that the slope of the y-intercept, which is of L, should be less than the y-intercept of M. Notice L has a lesser y-intercept. This is the y-intercept of L. This is the y-intercept of M. In this case also, if you notice, the line L has a greater slope. More angle, more slope. So if it has a greater slope, here also I'm being able to say that the slope of line L is greater than slope of line M. Okay. So in both the scenarios, we are getting the same answer, same result. And since we are getting the same result, we can answer the question. The question is the slope of line L greater than line M? We can say yes. Using this information given in statement 2, we can say that the slope of line L is greater than slope of line M. So the correct answer in this case is going to be option B. Okay, please let me know if this is clear or not. And in some slope questions in GMAT would be like this only, where you have to just draw and visualize. Notice once again, no calculation at all. I did not do any calculation. I just had to make sure that I draw all the cases which are valid to satisfy the conditions that are given in the condition. Okay. So any questions, please feel free to ask. I'm setting up the yes and no poll again. Abhi, steepness angles, they kind of signify the same thing, only more the angle, so that's okay as long as you understand this. What do you, Karan, can you please let me know what do you mean by examples? So as I told you that if you look at this line, okay, if the angle of the line, okay, when I say angle, remember I'm talking in terms of anti-clockwise direction, is less than 90 degree, it has a positive slope. That's one learning that you need to keep in mind. So if I draw a line like this, you have to basically, if you want to draw a line which has a positive slope, you have to ensure that the angle has to be less than 90 degree in the anti-clockwise direction. So all these lines that I'm drawing, these are all lines are positive slope because they're all, and notice again, I'm moving in the anti-clockwise. These are all positive angles. Okay. If I want lines which are, have a negative slope, then I will have to make sure that the angle is greater than 90 degree. So all lines that look like this, the good part is that you don't have to draw, new kind of lines. The moment you know how a positive line, a line with a positive slope and a line with a negative slope looks, you always can draw the same diagram. You don't have to draw different types. What I mean by that is you're not going to have a line like this with a negative slope. That's not going to happen. Okay, so a line like this less than 90 degree has a positive slope. A line like this with an angle more than 90 degree has a negative slope. That is all that you need to keep in mind, Karan. Okay. Minus 1.5 Anubhav. So guys, if you have any questions, any other questions, please feel free to ask. This was the last question for the day. Once again, I'm giving you a general reminder. If you want to, join our crash course, we are starting on April 24th. Please, you can get in touch with us if you want to, and we can let you know more about this. That's it from my end. Any other questions, anything at all, please feel free to ask. Anuv, it depends on the line, by the way, just to let you know. So obviously, as I showed you here, that there is it. Yeah, this one. If you notice, in this case, when you have a negative slope, the one with a negative slope out here, more slope, the y-intercept is less. And less and more, I'm obviously, when I'm comparing with M, then only I'm saying it. Okay. Yes, the crash course is an online course where where we'll be discussing so in the crash course, the course that you'll be using, apart from that, we'll also be holding live classes, online classes on each and every topic that we cover in our courses. So like, for example, we just did one webinar now, right, in geometry. But when you do join our online crash courses, we'll be doing more than one geometry classes. We'll be focusing more, covering less topics in a webinar. Like here, I covered 5 to 6 topics in one session. In our online courses, you have to use our course, and along with that, we'll be covering more number of topics, more number of questions, less number of topics in each and every webinar. If you want to know more specifically or anything about the crash course, please let me know. Or you can write to us on support also. We can give you more details on it. I'm sharing the email ID here. You can write to us and we can share more details on the crash course. Amna, it's because see, in data sufficiency question, if we can get the answer from one statement, then we don't need to combine both of them. That's like the most that's like the basics of a data sufficiency question, where you always try to get the answer from the first from the individual statements first. Once you get the answer from the individual statement, you don't need to combine them. Even if you can get after combining, you will not combine them. That's very important that you need to keep in mind, Amna. Anubhav, I'm not sure what you mean. If only intercepts are given, do we need to consider the sign for the comparison of intercepts? What exactly do you mean by that? Abhi, redundant statements, very rarely, very rarely, I would say, I've seen in GMAT. They don't. In fact, 1 or 2 questions maybe, but almost any information that is given in the question, be it geometry or word problem, any topic that you want to take, okay, information that is given is almost always used. So assumptions you should not do. That is one thing which I would want to put in mind, that you should not look at a triangle, and if it looks like a right angle triangle, you should not assume that's a right angle triangle unless until it says so. Okay, so from that perspective, don't assume. But if they tell you it's a right angle triangle, then it's a right angle triangle, and there's a good chance that it will definitely be used in some way or the other. Anubhav, usually GMAT does not confuse you by giving you, comparing these signs. So whenever they tell you the y-intercept is more or less, that they talk in terms of magnitude only. So you don't need to worry about the sign, Anubhav. I haven't seen any question like that, the way you're talking about, where we have to, take -3 and -5 and then compare it. No, I haven't. So I would recommend not thinking about it. Doesn't make sense. Slopes, yes, because slopes, positive, negative, everything depends on the, the sign. And so obviously the positive, negative will come into picture. In slope cases, yes. A positive slope will obviously is a positive slope, a negative one has a negative one. So the magnitude and the sign both comes into picture. Okay. Shikha, as I told you that we upload all our webinars on our YouTube. Okay, so I'm again sharing the link. It's broadcasted also. If you can just subscribe to it, you will be able to get access to all the recordings that we. So you'll get the notification as and when we upload it on YouTube. Okay. Any other questions, anyone? please feel free to ask it. You can ask general questions also. That's not a problem. Any GMAT related, quant related also. Please feel free to ask. Once again, if you want to know more about the crash course also, guys, you can ask me now also, or you can write to us also. That's not a problem. Yes, Anubhav, yes. You're welcome, Pooja. Okay, guys, I don't see any more questions. I'm ending the session now. All the best, everyone. Okay, Rohan, are you currently our GMAT student, or you're interested in just the GMAT course? I'm sharing the link of the GMAT crash course out here, Rohan. I'm broadcasting it also. So we are going to conduct, total 25 sessions. Okay, and it's a 13-week duration, and you're going to have 2 sessions per week for 2 hours. And obviously you'll also get access to our webinar, the course also. So the crash course works in this way, is that we use our course along with our these live sessions, where you cover a certain portion of the course from our platform, and then you come for these live sessions. Best part about these live sessions are those questions are not discussed in these webinars. Those are all crash course special questions, which are only discussed in those crash course. Okay, and they are much more in detail, in depth. So as I told you, here we were discussing 6 topics at a time, and I couldn't even cover 1 or 2 things. I couldn't cover any question on 3D today. But when you do a crash course live classes, where we ensure that we cover and touch each and every topic, and since there are 25 sessions, you can understand it's much more elaborate, much more in depth. And obviously the batch size is also really small. We don't have, so the interactions is much more better in these. Okay, so I've shared the link also of the crash course. You can look at the link, and just in case if you still have any questions, do feel free to write to us. Harsh, if you are a live student, then only you'll get access to it. If you are a GMAT prep student, or just a GMAT prep student, then obviously no. Crash course live classes are only for people who are avail for that. There's an option to upgrade also. So if there's somebody who is a current student and want to upgrade, I'm sure you must have got a mail a few days back. If you didn't, and if you're still interested in upgrading also, then you can upgrade to those live sessions. They can definitely help you out more, in just in case if you're more, like if you're going through the course also, and if you have any doubts or anything, those can also be discussed easily, because you're using our own course to prepare, and then you're coming for these sessions. So it complements really well. So anybody who is thinking of upgrading also, I think that's a good opportunity if you want to upgrade and have these sessions. Okay. Okay. Any more questions, anyone? Thanks, Amna. Anubhav, no, we don't share the PDFs of sessions. So you will have to just look at the webinar recording. Rohan, currently we haven't decided the date for the next batch, but most probably we may launch another one in May also. So most probably we'll be launching one batch every month. So if you want to join the next batch also, you can. We'll send you the notification for that also. One that we are starting now is on the 24th of April. The next one might start after a month, but the dates are not finalized, so I just don't want to commit. But there's a good chance we'll start another, after 24th May or something like that. If you're targeting round 1, then the best would be to join the 24th batch, frankly speaking, so that you complete it in, 13 weeks. And then you have sufficient amount of time to prepare for your mocks and fine tune your prep. So it depends on which round you're targeting also, so you can take a call based on that. Okay, guys, I'm ending the session now. Just in case if you still have any more queries, the email ID, you can see the email ID and a phone number. Please feel free to get in touch with us. Okay. So all the best, guys, and have a great day. Take care. Good night, guys. Bye.